You can use Pythagoras' theorem when you've got composite shapes. A composite shape just means it isn't a simple shape like a triangle or a rectangle, but it's two shapes joined together. If you look at this one here, you can see there's a triangle on the end here, but there's also a rectangle joined to it. This shape is a composite shape because I can split it up into two shapes that are smaller and worth the same. So when I split up my composite shape into two simple shapes, I can use the rules I know for those shapes. I know Pythagoras' theorem. I can use it to work out the sides of this triangle. The rectangle is just joined to the triangle, so I can separate them into two parts to work things out. Here is an example, and in this example I want to find out what the length of this sloping side here is, the hypotenuse for the triangle. This right angle here means that this is also a right angle here, because a straight line is 180 degrees. 90 plus 90 would be 180 degrees. So let's look at what I know. I've got these sides over here, 9, 4, and this long side all the way along there is 12. If I'm going to use the triangle, I need to know these two sides. There's a bit of a problem. I don't know those two sides yet, but I can use these other sides to help me work it out. This vertical side here is in the same direction as this vertical side here, 4. And because it's a rectangle, all the corners are 90 degrees. And what that means really is in effect that this 4 metres here will also be 4 metres here. So I can write 4 metres for this side, for this vertical side. Looking at the horizontal sides, I've got 12 all the way along here and 9 all the way along here. If it's 9 from here to here, it's also 9 from here to here. Simple subtraction shows me that side there must be 12, take away 9. So I can write 3 metres here. Now really what I've got now is just a triangle like this, with 4 here, 3 here, and x there. So that means I can use Pythagoras' theorem. Let's just label my triangle. This is the longest side, so it's C, and the other two are A and B. A squared plus B squared equals C squared. A is worth 4, so 4 squared plus B squared, which is 3, so 3 squared equals C squared. So B is 3, so B squared is 3 squared. A is 4, so A squared is 4 squared. Looking at my formula now, what I need to do is get C by itself. To do that, I can work out the numbers on the left-hand side, because I know that 4 squared is 16 and 3 squared is 9, so that's made it a bit easier. Oh, and 16 plus 9 is 25, so 25 equals C squared. If I square root both sides, I'll get rid of the squared because C squared and square root are opposites. So I end up with C equals 5 because the square root of 25 is 5. So C equals the square root of 25, 5. That means that this side here is 5 metres long. In this example with the composite shape, we're trying to find out what x is and what y is. X is the vertical height of the two triangles, and y is the horizontal distance of the larger triangle. You can see there are two triangles, a smaller one inside a bigger one. So the smaller one is 5x and 3, and the bigger one is x, y, and 10. Now that looks a bit complicated. So what's better is to actually split these two triangles into two separate triangles so you can see them more easily. Here you can see that the smaller triangle, which is this one, and the larger triangle, which is this one, can be separated into two triangles. This is 10, this is x, that's y, this one's 5, that one's 3, and that one's x. Now when you do that, and you look at your triangles, you can see this triangle has got two letters that I don't know. This triangle's only got one letter that I don't know. So what that tells me is I need to use Pythagoras' theorem on this triangle first to find x. If I know what x is, I can rewrite it here as well because these are both x. In fact, they're both the same side. This side here is this x and this x. So using this triangle to find the one I don't know, and then using it in this triangle to find the other letter that I don't know, the other pronumeral y, will mean that I can work out all the answers. So working out the first triangle with the x, so I'm working out this triangle here, the smaller one, with the x, 3 and 5, x3 and 5. Doing that, I need to write out Pythagoras' theorem, so a squared plus b squared equals c squared. Now let's label it. This is c because it's the longest side. This can be a and this can be b. Doesn't matter which one's a and which one's b. Now let's substitute in the values. Looking over here, c is 5, a we don't know, and b is 3. So that means I can write a squared plus 3 squared equals 5 squared. Again, I'm substituting, so b is 3, so b squared is 3 squared. C is 5, so c squared is 5 squared. Now, let's see what we can work out. A squared I can't do anything with. Oh, 3 squared is 9, so that's good. And 5 squared is 25. Now, I'm trying to find what A is. It's not by itself. I have to make it the subject. To do that, I need to get rid of this squared and the 9. I want A equals. So let's do that. First of all, I'm going to subtract 9 from both sides. When I do that, these two here make 0, plus 9 and minus 9 is 0. So I end up on the left-hand side of a squared equals 25 take away 9, 16. To find out what a is, I need to get rid of the squared, so I square root both sides. When I square root both sides, a squared and then square rooted just goes back to being a, and the square root of 16 is 4. So I now know that this x here is 4, which means this x here is also 4 metres. That will help me when I use my next triangle. So, using my first triangle, I found out that this x here was 4. And this big triangle, which is this one that I'm looking at now I know this side is 4, this side is 10, which is the hypotenuse, and this other side here I don't know. So we can go through the same process now, because now there's only one unknown, one letter I don't know, one pronumeral I don't know the value of. So let's look at it. I'm going to label my triangle. This is the longest side, so it's C. This is another side, a short side. It can be A, this one can be B. Let's write Pythagoras' theorem. A squared plus B squared equals C squared. Substitute in. A is 4, C is 10, B we don't know, which B is actually going to be Y. So let's substitute in. So A squared, 4 squared. B, don't know. I might put Y squared there because that's what I'm trying to find out anyway. And C squared is 10 squared. So just substituting in, B and Y are the same thing. C is 10, A is 4. So let's see if we can work out what Y is. To find out what Y is, so let's square 4 and get 16. We can't do anything with Y squared. Oh, 10 squared is 100. So now to find out what Y is, I need to get rid of the squared and the 16. So I need to subtract 16 from both sides. If I do that, these two make nothing. So I end up with Y squared equals 84. So Y is going to be equal to the square root of 84, because if I square root both sides, I'll get Y equals the square root of 84. And that's 9.2. So that means that this side here, this long Y side here, is 9.2 metres long. Here's another composite example. You notice that there are two triangles, one on the right and one on the left. The one on the left has got two numbers and one letter, y. Y is the unknown. The triangle on the right has two unknowns. So I need to work on the triangle on the left first because there's only one unknown value. So let's look at that one there, and I will label it. This is the long side, the hypotenuse. This side can be A, this one can be B. So let's write down Pythagoras' theorem. A squared plus B squared equals C squared. Substituting in, then I will have y squared plus 16 squared equals 20 squared, and that's because b is 16, so b squared is 16 squared, c is 20, so c squared is 20 squared, and a is y, so a squared is y squared. So that means y squared plus 16 squared equals 20 squared. So this value here is 256 and this one's 400. I need to find out what y squared is, so I need to subtract 256 from both sides because I want to get rid of the 256. And these make nothing. So y squared equals 400 minus 256, and that's 144. So square root both sides to find out what y is, because I need to cancel out the square. So y is equal to the square root of 144, which is 12. So that means that this side here is 12 centimetres. So having worked out that y is worth 12 centimetres, I can now use that value here that I now know, plus the 13, to get what x is. So let's write out Pythagoras', let's label it first. So C, A and B, A squared plus B squared equals C squared. Now in my equation here, A is worth 12, B I don't know, but it's going to be the x, and C is 13. So A squared is 12 squared, B is x, so B squared is x squared, and C is 13, so C squared is 13 squared. 12 squared is 144, 13 squared is 169. I need to subtract 169 from both sides. 144 plus x squared equals 169. So I'm going to subtract 144 from both sides of the equation, keeping it balanced by doing that. These two subtract to make nothing. So x squared equals 169, take away 144, which is 25. Need to find what x is, so I need to make x the subject, so square root both sides. And when you do that, you get x equals 5. So this side here is 5. So I've now calculated using Pythagoras' theorem on this triangle and then that triangle. First of all, I've calculated that this is 12 and that's 5.